Okay, so let's talk about project now. So for projects, you will be provided this data folder with files. Um, and these files contain information about printed words, something like this. The word, the year, and how many times this word was printed during this year. And after the last year is 2008, I believe. So after it reaches the last year, then without any spaces on the new line, there will be another word and also years and counts. So because you can imagine that there are so many words, we split this document into smaller parts so you can run and test your code faster because it will take some time to go through all the words. So the file with words beginning with A, with Z, with vowels, and very short, you will see later example, there are just few words. And also, we asked you to write 4 functions, and for each function, you are provided with test files. So, in addition to 4 function, there is function 0. So, in general, in total, it's 5 functions, which will read your data. And we ask, oh, here's the example of very short file. So just 3 words and just several years instead of the entire range. You can take some breakfast. So um, so we ask to store your data in dictionary of dictionaries. So the keys for outer dictionary, the keys are the words. The values for these words will be another dictionary. So inner dictionary contains keys years, and values will be counts, how many times this word was printed during that year. So for this short data set, this data structure looks like this, like the word and corresponding dictionary with years and counts. So I can show example. So here is my data structure, the dictionary of all words, and I'm using a key, one word, and I will just print it now. And yeah, this is how your project will look like. Data folder, your files, and testing files. So here, for example, it asks to enter the file name. If we use just words beginning with a.txt. What? Oh, I made a misprint. Then it asks for the word, for example, here. And then it prints how many times this word was printed over all years. So it sums up all the values of the inner dictionary. And because I used print, here is how this inner dictionary looks like. So year count, and so on. And then you sum up all these counts. And this is what this function returned. If you print the word which is not represented in this in this file, it should return 0 count. So, for example, ATXT, and the word beginning with B, it should return 0. So this is task 0, to create a data structure. And all the other files, they will use the data structure that will be created by your first file. So they will call, for example, you will use import word data, or maybe from word data import start asterisk all the functions. Yeah. And each file has the testing functions. So the first task is to count the frequencies of all characters. So how many times, for example, character A was printed over all years and in all the texts. And then you will plot this distribution of characters. It's called bar plot. Because here we used a very short file, some characters were missing in this file, but of course, when you will use all words, you will see all the characters. Otherwise, why do we need extra characters? So, and you will see actually which characters in English are used more frequently, and it won't be A. So, yeah, and you can see that the range is pretty high. Just for small data, it's 10 power 6, but for the entire data set, it should be very high. So how to plot this bar plot? We provide the code. You will import matplotlib library, and there is a command bar. So you will call matplotlib.bar. Your input will be array with frequencies of letters, and it will plot the distribution of these letters. Okay, so this is task 1, to count frequencies of characters. Task 2, to calculate how many words were printed for each year. So, for example, this is the list of tuples. Each tuple has year and number of words printed during this year. So again, you can plot this with matplotlib. You will need to pass 2 arrays. The first array will be array of years. The second array will be the array of counts, and it will print this plot. The x-axis will be the first array, the y-axis will be the second array. So yeah, and you will see this exponential trend for the number of printed words. Does it make sense? Okay, let's go to the next task 3. So as you can see here, the user can input the two numbers, the beginning date and the ending date. And you will write a function that calculates how many times this word was printed, but in this range. Not overall, but only between these years. And then you should sort this, whatever data structure you will use, by frequencies. And for example, we will ask to print top 10 words. So you will just take a slice from the beginning, or 10 like less frequent words, you will take a slice from the end. And here we also ask to skip the words that were very rare. The words whose frequency was smaller than 1000. So this list should contain the words with frequency greater than 1000 only. Okay, so this is the most popular words during this time period. And finally, task 4. In task 4, we ask to find similar words. Here is example. The user types the word, and your code should provide 5 similar words. So the first word, of course, will be similar to itself. And you can see that other words are also maybe related to the robot. So how to find these similar words? We will use so-called cosine similarity. So your data will be represented as this table. Okay, you can sleep. I'm recording. So yeah, don't worry. You can watch it later. So or you can take some more food. So your data will be represented as this table, the word and counts for each year. So each word will be represented as a vector of about 108 years. And we call these features. So it will be represented with 108 features. So if a vector has only 2 features, we can visualize this on the plane, the vector with 2 coordinates. And the vectors we will say that the words are similar if their directions are close. So, for example, for the word, I can annotate. For example, if we have vector A and vector B, how to calculate the angle. I can use alpha, I can use phi. How to calculate angle, maybe it's more familiar. Theta. How to calculate the angle between, I will use alpha, between vectors. Or do you know what is the dot product? So okay, maybe I'll ask differently. So instead of evaluating angle, can we evaluate cosine of this angle? What is the cosine, for example, of 0 or and what is cosine of 90 degrees? Yes. For 0, it's 1. Yes, and for perpendicular vectors, so the definition is the cosine is the, if we build this triangle, the cosine, so how to denote this? I know, let's note this maybe. I used A and B. This is the projection of B. I don't know, let's note this X, and this is Y. So the cosine is the ratio of X to Y. So if the vectors are perpendicular, X will be 0. The projection will be 0. Does it make sense? So for 90 degrees, it will be 0. And what will be the cosine of pi of 100 of just the vectors with opposite directions? -1. So the cosine for these vectors will be -1. So instead of finding the angle, we actually can find the cosine of the angle, and we can say that vectors are close if cosine is close to 1. Does it make sense? So that's why we will use cosine, and cosine is easier to calculate. If you know cosine, you can take the inverse cosine and you will get an angle, but it's an extra operation. So instead of finding angle, we will find cosine. So now how to find the cosine? Here we will need the notion of dot product. A times B vectors. If you don't know, the definition is that it's the absolute value of one vector times absolute value of another vector times cosine between those vectors. So from this formula, we can derive cosine, and cosine will be the dot product over absolute values. Oh, yeah, this is the formula in the bottom. So this is the dot product over absolute values. And you can just derive it from the definition of dot product. The intuition between this dot product is pretty simple. what is how to write this projection of vector B to vector A? It will be the length of vector B times cosine of alpha. So geometrically, this part, B times cosine alpha, is just projection of vector B to vector A. And our vectors will be pointed to the similar direction if this projection will be close to the and here's a tricky part. Close to what? Our vectors have different lengths. But if we normalize our vectors, and to normalize a vector, you can just divide the vector by its length. Then they will lie on the unit circle or unit sphere in multi-dimensional space. And then, if we take projection of one vector to another vector, the maximal projection will be 1. So if you normalize your vectors, then we can say that vectors point in the similar direction if the projection of one vector to another is close to 1. So this is the geometric interpretation, and here is the formula for normalized vector. It's squares are missing. So the absolute value is the square root of the sum of squared coordinates, and we just divide each coordinate by this absolute value. So let's go back to our example with birds. So in your project, this will be one vector. Let's call it word 1. It will be represented by these numbers. So now you have, instead of 2 coordinates, 108 coordinates. So we will find the angle in 108 dimensional space. Well, not angle cosine, but it's the same. So let's say this number is x1. Yeah, so like here, this number is the second component of the vector, and so on. And there is 108, maybe 109 if we begin with 1900. I don't remember exactly. So, but at least it's more than 100 components for each word. And this is word 2, for example, W word 2. With components y1, y2, and so on. So the formula for cosine will be between these vectors w1 and w2. sometimes you will see here hat, which indicates the angle between these vectors, like this triangle. Will be the dot product. Well, if you don't know what is the dot product, maybe you don't know how it's evaluated. So the dot product is calculated like this. You take the product of each component, x1 times 1, y1, and sum up all these products, plus x2 times y2, and so on. So this is the formula. So you remember the dot product was the cosine was the dot product over absolute values. Um, so the numerator, the dot product, can be calculated as the sum. So you take that's the product of first components plus the product of second component. X 108 or 9, what is the length of your vectors? It will be numerator, and denominator will be square root of the sum of squares, x1 squared, x2 squared, and so on till the last component. So do you want to make a short break, or we will continue with what do you think? I mean, I think just one slide left. If you want, we can continue and we'll just finish the video. Okay. Yeah. So okay, so this will be your formula for cosine. And you take the word, for example, the word for which you want to find similar words. And calculate this value with all other words. So then you sort these values and in decreasing order and take top 5. So it will be your first most similar words. Does it make sense? Okay, so the problem, so just one question to figure out if you understand. What if we take what if we calculate this formula for the word 1 with itself? What will be the value if we calculate the cosine between W1 and W1? So it means that each y will be the same as x. What will be the value? Yeah, yes, it will be 1. So, and it makes sense because we know that cosine of 0 is 1. So that's why when you saw top similar words, the first word was itself. It's most similar. Okay. The problem, so the only problem with this formula is that if you take the products and you can see that numbers are going very high for like following years. And if you take the product of these numbers and sum up, you will get a really huge numbers. And it's not a problem in Python for integer type, because if you remember, integer is unlimited in Python. Well, just with your machine memory. But when you divide, it will be casted into floats. And floats, they have type float 64. So the maximum number is 2 power 64. And you may run into the problem of overflow. Actually, I ran into this problem when I created this assignment. So you will run the test file, and even though your code is correct, you will get wrong in the test file because somewhere you got overflow, and that means that you got just wrong numbers for counts. So to avoid overflow, we recommend to normalize vectors first. So as you remember, so I mentioned that we can divide our vector by length, and then the length will be 1. So instead of taking dot product and dividing by the product of lengths, which are huge numbers, you can first normalize your vector and then take dot product. When you normal, so instead of taking dot product between W1 and W2, okay, I lost my, so, oh, I don't see the mouse. I hope it will appear. I even don't see mouse here. Oh, sorry. Sometimes it happens with Zoom running. I can use tab, but I don't see my pointer. What's going on? And so, I'm sorry, there's still no pointer. Um, okay, let's try. Oh, here it is. Great. Yeah, it sometimes happens with Zoom. So, sorry about that. So instead of multiplying W's, but first we'll divide these vectors by length. And if we divide them by length, instead of huge numbers, you will see numbers smaller than 1. And if you take the product then of numbers smaller than 1, the product will be also no greater than 1. So you won't run in this overflow problem. Okay, I think that's, yeah, so here are the formulas. So instead of multiplying vectors x and y, we will multiply normalized vectors x and y, and normalized vectors means that each component divided by x. Absolutely. So, and last thing, I will show how to implement this in code with NumPy. Of course, you can use a list comprehension and for loops to divide every component by absolute value. But there is a better way. To use NumPy library, which is the library for linear algebra operations on the vectors to calculate the absolute values, to calculate the dot products. So instead of writing for loops, let's create a new file. I will write just 7 lines of code, don't worry. And we will stop there. So again, you can use for loops, it's totally fine, but I will show how to use NumPy library for the same task. So if you don't have NumPy installed, you can install with pip install or pip3 install. So for example, we have the vector 1. I will just use arbitrary numbers. And the length will be 3. In your case, it will be more than 100. So NumPy has a function to calculate the absolute value. For example, W2 or W1 normalized will be W1 over the absolute value of W1. So in NumPy, first, if you divide the list by a number, you will get an error. But if you cast your vectors, your list into NumPy data type array, then if you divide your vector by a number, every component will be divided by this number. So it's very convenient. So then you can divide by your vector by a number, and this number should be np dot lin alg dot norm of W1. So this will calculate the absolute value of your vector. Instead of writing for loop and take the sum of squares of each components, then square root, you can just use this code. And then we will normalize the second vector. So first we cast into NumPy array. So now, if I print one of these vectors, you will see that it's normalized. And the sum of squares, if I take the squares and sum, it should be 1. Yeah, it's almost 1. Again, because floats, the floats, they have limited range, so we see the rounding for the float data type here. Okay, and finally, if we want to calculate the dot product, which is, you remember, we take the product component wise and sum up. Again, you can do this just with one function, np dot between two normalized vector subs. And the dot product between two normalized vectors is the cosine. So this is, I just wanted to show you how you can calculate cosine between two vectors without any for loops. So the only thing that I want to mention, for some years you won't have any information. For example, this word anticoagulation didn't appear until 1906. So you will need to insert zeros for missing years, because you can't calculate the cosine between vectors of different length. So you should insert zeros for missing years, and every word will be represented by the same number of years. Okay, do you have any questions? So next week is a normal week, but the Thanksgiving week, there won't be a lecture, but if you have any questions on the project, you're welcome to come. So it will be just the project consultation. Okay, then we're done for today. Feel free